Hello everyone, and welcome to the EsmaCAT 16 channel analog input tutorial. In this video, we will demonstrate how to read single-ended analog inputs by using EsmaCAT. The EsmaCAT 16 channel analog input is an EtherCAT-based analog voltage input interface. It can read 16 single-ended or 8 differential inputs with various programmable ranges. Here, we would like to demonstrate the reading of a single-ended input. Now let's get started. In order to read analog voltage inputs, we need several EsmaCAT components. First, we need one EsmaCAT master device. In this tutorial, we will use the dedicated EsmaCAT Server S as our master, but any Windows or Linux machine can be used as the EsmaCAT master by downloading the EsmaCAT Server software from EsmaCAT.com. Second, we have to prepare one EsmaCAT slave set. This set consists of a 16-channel analog input, and we will connect it to a potentiometer to demonstrate a varying voltage signal in real time. In this tutorial, we are going to use EsmaCAT's auxiliary output voltage as a potentiometer voltage source. The EsmaCAT master and slave set will be connected to each other and communicate via the EsmaCAT PoE or Power over EtherCAT. This enables our master to provide both communication and logic power to the slave over a single Ethernet or RJ45 cable. Here is the potentiometer hardware setup that a lot of us might already be familiar with. On the left, we see that the potentiometer receives plus 5 volts and ground from the VDD5 and GND pins in the analog input connector, while its signal wire is connected to channel 0. On the right, we have the PoE system that was discussed earlier. When we connect all the components as shown, our hardware setup is complete. Now, let us write our code together. We can start with the template that is included in the EsmaCAT Server Software Development Kit. Let's open the header file. We need to create one object for EsmaCAT slave to represent the type of slave that we wish to physically use. Under private, we create a pointer to an EsmaCAT analog input object for this purpose. Next, let's look at the source file. In the connect function, our declared object needs to be connected with the actual EsmaCAT slave. The function, named as assign EsmaCAT slave index, is for this connection. Because the analog input board is the first, and in this case the only, slave connected to the EsmaCAT master, let's assign our object ECAT-AI the index 0. Let's move on to the setup function. Because the analog input board can read 2 different types and various ranges of signals, we need to set options for input channels to acquire proper inputs based on our purpose. For this, let's declare analog input option object first. After declaring the option object, we can set analog input configurations. The 16 channels are grouped into sets of 4, each with an assigned variable in the EsmaCAT analog input object. The user can set the type and range of input signals that each group of channels can read by using this object. In this tutorial, we will set the parameter to read single-ended 0 to 6 volts DC because our measured voltage is in the 0 to 5 range. Last, we push this configuration object to ECAT-AI using a system set param function. Our setup is now complete. In the loop function, we will write a line to print out the elapsed time and the single-ended voltage input in channel 0. This is to output the measured voltage to our screen as a demonstration. And now for a demonstration. We can see here that as we turn the potentiometer knob, the signal voltage created by its voltage divider changes. This is picked up by our EsmaCAT analog input and displayed on screen. For more information and tutorials, visit our website EsmaCAT.com and our YouTube channel EsmaCAT.